Galaxies have been discovered that appear to defy the laws of physics as we know them and appear to have existed before the Big Bang, the time once thought to be the birth of our universe. This revelation has challenged basic theories of the universe, including the Big Bang itself, and has sparked heated debate and intense research around the world. As we stand on the precipice of rewriting our entire understanding of the world, an important question arises. What if everything we thought about the world was wrong? For nearly a century, the Big Bang Theory was the cornerstone of the universe. The universe is thought to have begun as a single particle, a mass of heat and mass, 13.8 billion years ago. This singularity expands rapidly in a cataclysmic explosion, creating all matter, energy, space, and time. The Big Bang Theory is not just a hypothesis, but a framework supported by a lot of observational evidence, including the universe's microwave background radiation, abundance of light elements, and change rate of distant galaxies. These observations have long been interpreted as indicative of a wider universe, a theory first proposed by Edwin Hubble in the 1920s. However, new JWST observations challenge this theory. The telescope's ability to view distant galaxies in greater detail than ever before has made objects that, with all current knowledge, should not exist. Galaxies have been found that appear to have formed less than 200 million years after the Big Bang, a period previously thought to be too chaotic and energy-dense for galaxies to coalesce. These galaxies, like the infamous glass Z13, not only exist but also appear to be fully formed, with structures and star systems that suggest a level of maturity that defies the conventional timeline. The discovery of these so-called impossible galaxies has sent shockwaves through the scientific community. Galaxies like GN, Z11 and Glass Z13 have been observed at distances that place them nearly 13.4 billion years away, meaning their light has been traveling to us for almost the entire age of the universe. This in itself is not necessarily surprising. What is shocking is that these galaxies show signs of being fully formed, with mature stars and complex structures that should have taken billions of years to develop. For example, GN Z11 was first discovered by the Hubble Space Telescope and later confirmed by JWST. It is 13.4 billion years old, making it one of the oldest known objects in the universe. However, its apparent age suggests that it formed earlier than current models of galaxy formation. The discovery of GN Z11 alone was enough to raise eyebrows, but it is only one of many such galaxies that have been discovered. Glass Z13, another galaxy discovered by JWST, is more ambiguous. This galaxy appears to have formed 200 million years after the Big Bang, but shows signs of a fully developed galaxy. This rapid formation challenges the old view that it took billions of years for galaxies to form from the initial soup of particles left over from the Big Bang. The existence of such galaxies suggests that galaxies are forming faster than previously thought, or more worryingly, our understanding of the universe is wrong. As these impossible galaxies continue to baffle scientists, some have begun to look into the work of a long-forgotten physicist, Fritz Zwicky. Zwicky, a Swiss astronomer and physicist, was a contemporary of Albert Einstein and Edwin Hubble. Although he is best known for coining the term dark matter, Zwicky also proposed a theory that may explain the JWST observations, the faint light theory. According to Zwicky, the moon is not stationary as it travels through space. Instead, he thought that light would lose its energy over time, a process he called exhaustion, and that light would shift toward the red end of the spectrum. This idea, known as the weary light hypothesis, was rejected by the scientific community in favor of the universal model proposed by Hubble. However, the discovery of galaxies like GN, Z11 and Glass Z13 caused some researchers to question Zwicky's ideas. If light gets tired as it travels through space, this could have a profound effect on our understanding of the universe. For example, redshifts seen in distant galaxies, long interpreted as signs of the wider universe, are a sign that the moon is losing energy far away. Or maybe not. Also, if the speed and behavior of the moon varies over time, the methods we use to measure Earth's distances may be wrong, making estimates of the distance inaccurate. Number and size of the world. Zwicky's exhausted light theory, although still controversial, provides an alternative explanation for the JWST observations. It suggests that the light from these impossible galaxies has been traveling for much longer than we currently believe, meaning the universe could be much older than the 13.8 billion years suggested by the Big Bang Theory. If Zwicky's hypothesis is correct, it would not only explain the existence of these ancient galaxies, but also force a radical rethinking of many other aspects of cosmology. The revelations brought about by the JWST have not only revived interest in Zwicky's ideas, but also spurred the development of new theories about the age and nature of the universe. One such theory has been proposed by Canadian physicist Rendra Gupta, who suggests that the universe could be much older than previously thought, possibly as old as 26.7 billion years. Gupta's theory is based on the idea that slight modifications to certain cosmic constants, values that describe the behavior of fundamental forces in the universe, could lead to a much older universe. By correcting these constants, Gupta showed that the age of the universe could be calculated at about twice the current estimate. This helps explain the existence of galaxies like GN, Z11 and Glass, Z13, which appear to have formed before the Big Bang is thought to exist. But Gupta's theory doesn't stop there. He also says that with other changes to these climate variables, the universe will be 40 billion years old. The massive increase in globalization will have profound implications for our understanding of world history. This means that galaxies, stars, and other structures could have been formed much earlier than previously thought, and the way the world looks today is the result of processes that took longer than we thought. AI. This theory is similar to the ideas of another famous physicist, Sir Roger Penrose. Penrose proposed a cyclical model of life in which the world goes through cycles of birth, evolution, and death. According to Penrose, the world we live in is the last part of the universal age, which ends with a great separation, the collapse of all matter into a singularity, followed by other great cities. Penrose model of the world around him. It also includes the concept of black holes, which are important to transition from one age to another. In his model, black holes are the last things left at the end of life in the universe. After the available resources are exhausted, these black holes shrink or collapse, giving birth to a new universe. This process of recycling matter can and has the potential to explain how galaxies like GN, Z11 and Glass, Z13 formed shortly after the Big Bang. If there were any remnants of the old world. As the debate over the age and nature of the universe continues, some scientists are turning to quantum physics for answers. Quantum physics, which deals with the behavior of particles at very small scales, has long been at odds with classical physics, which deals with larger objects such as stars and galaxies. This disconnect has led many scientists to believe that there is a flaw in our current understanding of the universe, a flaw that could explain the mysterious JWST observations. A prominent proponent of this idea is Michio Kaku, a physicist and futurist philosopher who has written extensively on the mysteries of the universe. Keiko believes that JWST's observations are a strong indication that our current models of physics are wrong. He argues that quantum physics, with its strange, often counterintuitive principles, may hold the key to unlocking the true nature of the universe. Kaku points to the phenomenon of quantum entanglement as an explanation for the rapid formation of galaxies such as GN, Z11 and Glass, Z13. In quantum entanglement, particles that are separated by vast distances can instantly affect each other's states, suggesting that information can travel faster than the speed of light. If this phenomenon occurs on a cosmic scale, it could explain how galaxies could form and evolve much faster than currently believed. Another area of quantum physics that could have implications for cosmology is the concept of the multiverse, the idea that our universe is just one of many parallel universes that exist simultaneously. Some theories suggest that these universes could interact with each other, exchanging matter and energy in ways that could explain the JWST's findings. For example, if our universe is just one of many in a vast multiverse, it's possible that the galaxies observed by the JWST are not as old as they appear, but are instead reflections of galaxies in a neighboring universe. Although these ideas remain speculative, there is growing uncertainty and concern in the scientific community. As JWST continues its exploration mission, our lack of understanding of the universe is becoming increasingly clear. The telescope's discoveries not only challenge existing theories, but open up new avenues of research that will revolutionize our understanding of the universe. As scientists grapple with the implications of JWST's findings, space around the world is being explored and reevaluated. Whether the universe is older than previously thought or our methods of measuring cosmic distances are flawed, There has been a new wave of research aimed at solving these questions. One area of focus is the study of cosmic inflation, the rapid expansion of the universe believed to have occurred in the first fraction of a second after the Big Bang. Although the theory of inflation has been successful in explaining many aspects of the universe's large-scale structure, the JWST findings have raised questions about its validity.